Hi, welcome to our second lecture in this chapter on Earth patterns that result from revolutions and rotations. We're just going to quickly review what three things cause the change to sun rays angles of incidence hitting a planet. First is that the Earth is tilted on its axis at 23.5 degrees. Second is that tilt is oriented in the same direction, and there's no precession, meaning that it doesn't wobble like a top. And third is that the Earth revolves around the sun. If you changed any of these variables, some really interesting stuff would happen. Seasons would totally be different. Day and night patterns would totally change. We'll do a lab on that called RSI seasons in a few days. Okay, so I want to go over a couple of key important latitudes on Earth. First, let's talk about our axis. Our axis is up here. It's this pointy thing right here. I added this little vertical line because that's what our degree is measured from. This is a 23.5 degree angle off of vertical, and that's what is our axis. So starting at the top here, let's start in the middle. Our first latitude that's important is this one right here. That's our equator, and that is said to be at 0 degrees. Going north and south, you have these tropical lines. The one in the top is called Tropic of Cancer, and the one on the bottom is Tropic of Capricorn. What I want you to notice is that these two occur at 23.5 degrees. That's not a coincidence. These latitudes are important because at certain times of the year, specifically the winter solstice and summer solstice, these latitudes will basically negate the tilt of the Earth. And so sunshine will directly hit this. If it's our summertime in the northern hemisphere, sunshine will hit this latitude at exactly 90 degrees directly overhead. And then in our winter time, sunshine will hit this latitude in the southern hemisphere at directly 90 degrees. So basically, anywhere between these two tropics lines, which is why this area of the world is called the tropical region, you can have 90-degree sunshine. North of these latitudes, you have the Arctic Circle and the Antarctic Circle. These occur around 66.5 degrees, north or south. What's interesting and noteworthy about these latitudes is that above this latitude and below the one here that's not really pictured, in these areas of the world, you can have 24 hours of light and 24 hours of darkness, depending on what solstice is occurring. Lastly, it's important to note that our Earth rotates in a counterclockwise motion when viewed from above, when viewed from the North Pole. So let's take that into our ecliptic view, and we'll kind of uncover some important events. Right now, let's first figure out the solstices. Right here we have the globe, and you can see that I've labeled the axis as oriented towards the sun. So that would make this our summer solstice, which occurs around June 21st. Sometimes it's the 22nd or 20th, but it's around the 21st. That would make this the winter solstice, and if we know that the Earth revolves in a counterclockwise motion, that would make this the spring equinox and this the fall or autumn equinox. Again, these dates that are happening, the 21st, they're usually around the 21st, but they can be off by a day or so sometimes. So the summer solstice brings in summer. So that means that the time between June 21st and September 21st, that's our summer, fall, winter, and spring. We did this lesson in January, so that's what this X is supposed to denote. This is about where we are currently as I'm making this video in our path around the sun. That path is called the ecliptic, and that's represented by a dotted line. Okay, a couple of quick vocab words that I want to go over before we continue on. You should know what celestial altitude means. It's basically referring to how high an object appears in the sky. Remember, stars and suns and moons, it's difficult to measure how far they are off the Earth's surface in feet, in units of distance. So instead, we just look at where they appear in the sky and measure that angle relative to the horizon. So for example, if this is a star right here in our sky that we're interested in, we would measure the angle that it creates from the horizon, and that would be the star's altitude. The highest altitude you can get is directly above, which would make a right angle, and therefore that's 90 degrees. The lowest altitude you can get is when the star is on the horizon, which would be an altitude of 0. The zenith is a term that refers to the highest point reached by an object in the sky. Now, the highest possible zenith is 90 degrees, but that doesn't mean that every object gets 90 degrees in the sky. Sometimes our sun only gets up to about 70 degrees or 60 degrees. So whatever the high point is during the day or night or whatever time you're looking at an object, the zenith refers to its highest point in the sky. Throughout the year, the sun's apparent altitude does change and appears higher or lower. So if you're at a school, this is the point of the observer and you're looking south, this way is south down here, the sun's going to rise in the east, come across our southern sky, and then set in the west. In the wintertime, that path is very low in the sky. At first, it arises south of due east, and it stays low, and then it sets south of west. But in the June sun, in the summertime, the sun rises north of east, comes across our sky at a very high angle, close to 90 degrees, and then sets north of west. And between December and June, the path of the sun would be in this region. It would just kind of come up a make different arcs across the sky. That sun's zenith changes every day, increasing during spring and decreasing during fall. So again, I don't know if you can see this, but this is kind of an image of the sun going up and down if this is the wintertime, if this is the Arctic, then we're within the Arctic Circle, and you'll have 24 hours of sunlight as it kind of circles around you. Just a couple of quick notes to make sure that you're not confused by anything. There's several things that we'll be talking about that are measured in degrees. Don't let that confuse you. So temperature is measured in degrees, whether that's Fahrenheit or Celsius. The tilt of the Earth is also measured in degrees, but that's a constant value of 23.5 degrees, and that is measured off a vertical plane. Latitudes on Earth go from 0 at the equator to 90 at the poles. The angle of incidence refers to the angle of sunlight coming in, and that can also range from 0, which would be no light, to 90 if the sun is directly overhead. And then the celestial altitude, as we just learned, ranges from 0 to 90, depending on where the object in the sky appears relative to the horizon. Okay, so that's it for this lecture. I'll see you soon.